So here we have a program that counts the amount of lines in which a string occurs, or a substring occurs in a string. In this case, the string is a file and the substring is something we are passing as an argument, the first argument. If we do this, we have found that there are 4 lines in .cshRC in which ZSH occurs. And we can check that, of course. 1, 2, 3, 4. So what's the problem here? If you are using GNU, this stir is kind of wasteful, because every time we're calling stir, we're also calling strlen to find the strlen of both of the strings, because we're just passing 2 char pointers, and stir somehow needs to find the null terminator. If you use GNU, there is a function called memmem, which is the same thing, but you will need to pass the haystack length and the needle length. And in this case, we can do that because we know we're testing the same strings. The length is not really gonna change. So we can do file size for the file. And for the word, we can count the length of the word we're trying to test here. So word length, strlen, word. Right? And then we can also change stirchar to memchar, which this is a standard function, not a GNU one. So pass the length. Okay. So if we run this, it's 1. But why? That's kind of weird. With stir, we had 4 lines. So the problem here is we're passing the wrong length, really, because the haystack is not just file size, because on the second and third and fourth iteration of this for loop, the found has moved to the occurrence of the substring, right? So if we, for example, have string hello world, and then we do like a stir on it, or like memmem, and the substring, for example, is wo. Now we're pointing to wo, right? Or the w. So the length of the string, or the where the string ends, is no longer strlen hello world, but it's strlen world, right? Because we're pointing to w here. So to fix that, we will need to update the haystack length to correctly know where the end of the string is. So to do that, we'll just do file size minus equals. And how do we get the strlen actually from the string to the new pointer? Well, memmem itself doesn't return a strlen, but it returns a pointer. And with pointers, as they contain a memory address, we can just do found minus old, and I guess do old equals found. So we're saving the old string before which we call memmem. After the memmem is done, we will calculate the length between the old and the new, or we'll just calculate the length we have jumped with memmem. So I guess we can, so if it's a hello world, all points to hello world, right? And then let's say we're doing a mem to find the substring wo. Found is now pointing to world. So if we old minus found, it's just going to check from hello from h to wo, right? And then we get the strlen. So we'll just update the file size, and then we can also use memchar, which is a standard function, and then do the same thing. So we'll just update it again. Found minus old. We're going to update old here to point now to where the mem points to, and then yeah, it should now correctly update the haystack length. And so if we compile it, oh my gosh, okay. Wrong arguments. Okay, and if we do that, it's 4. Okay, if you already know beforehand or can keep track of the length of the strings, it's probably better to use the mem functions. But well, if you don't have GNU, then well, you probably should just use stir or make a macro to wrap it to check if you have the GNU function beforehand. And if not, you make a fallback and to use stir or like implement your own, but the stir is probably faster than like handwritten code. So yeah, hope that helps, and yeah.